Next example, expand exponential sine x up to the term in x raised to power 4 using Maclaurin series. Hence, integrate the integral from 0 to 1 of exponential sine x dx, isn't it? Now, for you to expand this function in Maclaurin series up to the term in x raised to power 4, meaning we are going to differentiate the function up to the fourth derivative, isn't it? So that is where we start from before we write the Maclaurin series itself, isn't it? So the first thing, you know, you've been given the f of x to be exponential sine x, isn't it? Are we together? So we have to differentiate it up to the fourth derivative is when we can get x raised to power 4, isn't it? Are we together? So we start, if we differentiate it for the first time, if we differentiate an exponential function, it remains the way it is. Then you differentiate the inner function. The inner function is sine x, isn't it? If you differentiate sine x, you get cos, meaning it is times cos x, isn't it? Then you differentiate the most inner, which is x, you just get 1. So you will end up with cos x exponential sine x. Are we together? We move to the next one. We differentiate it for the second time. Now, if you are differentiating this for the second time, you can see it is product rule, isn't it? Cos x exponential sine x. So it is product rule. The first part is u, the second part is v, isn't it? Are we together? So you have u is equals to cos x. So if you differentiate cos x, you are supposed to get negative sine x. Are we together? Then you go again, your v is what? Exponential sine x, isn't it? So if you differentiate v, what do you get? If you differentiate exponential sine x, it remains the way it is, isn't it? Then you differentiate the inner function sine x, you get cos x. Then you multiply the inner function times the outer function, isn't it? Are we together? So you know, if you have u and v in product rule, you are supposed to get u, v. So if this is u prime, the other one is v prime, isn't it? Are we together? So start u prime times v. What do you have? U prime times v. Negative sine x exponential sine x. You get is equals to negative sine x exponential sine x. Then it is plus u v prime, isn't it? It doesn't matter what you start with. Whether you start with this or this, it doesn't matter, isn't it? So then times u v prime. What is u v prime? Cos x times cos x exponential sine x. So cos x times cos x is cos squared, isn't it? So it is plus cos squared x exponential sine x, isn't it? Are we together? So you get cos squared x exponential sine x. If you multiply u times v prime, cos times cos is cos squared exponential sine x. You are done with that, isn't it? We now move to the third derivative. We now differentiate. If you differentiate this, you get triple prime, isn't it? So differentiating the first part, what do you get here? So you can see both of them are product rule, isn't it? So what will we get? Start with this first part. We have negative sine x exponential sine x, isn't it? So you let this to be u and the second function to be v, isn't it? Are we together? So you say u is negative sine x, isn't it? U is negative. So if you differentiate u, what do you get? Negative you factor outside. If you differentiate sine, you get cos x, isn't it? So it is going to be negative cos, because that negative v was outside times cos x, isn't it? Then what is your v? Your v is exponential sine. So if you differentiate v, what do you get? If you differentiate exponential sine x, you get what we got there. So outer function, it remains the way it is, isn't it? Exponential sine x, isn't it? Then the inner function, if you differentiate sine x, you get cos x. So if this was uv, meaning if you have uv plus uv, if this is u prime, the other one is v prime, isn't it? So it is u prime times v. What is u prime? Negative cos x times exponential sine x, isn't it? So this times this, you get negative cos x exponential sine x. Then it is plus u v prime, isn't it? U is Negative sine x times v prime is that, cos x exponential sine x, isn't it? So what will you get? You get negative sine x cos x exponential sine x. Are we together? See, you are done with this first part. Then you go to the second part and you add to that, isn't it? You go to this second part. So what do we have in that second part? The second part we have, it is cos squared exponential. So this first function to be u, the second function to be v, isn't it? Are we together? So u is equals to cos squared x, isn't it? So if you differentiate u, what do you get? If you differentiate cos squared x, what do you get? You get negative 2 cos x sine x. This is because like this, cos squared x is this. It means it is cos x which has been squared. So if you make cos x to be t, meaning you have t squared as the outer function, isn't it? So if you differentiate t squared, you get 2t. And your t was cos x. So that means now you get 2 cos x if you differentiate the outer function. That is the outer function. Then if you differentiate the inner function cos x, you get negative sine x. So what do you get then? See, negative 2 cos x sine x. Are you seeing that? Because cos squared x is, there is an outer function, that squared is an outer function, isn't it? Then the inner function is cos x. Are we together there? Good. So that is that. Then you move to the next one. Your v is exponential sine x, isn't it? If you differentiate v, what have we been getting? Cos x exponential sine x, isn't it? So if you have uv, what will you get with derivative? uv plus uv. If this is u prime, the other one is v prime, isn't it? So start. U prime times v. This is u prime times v, isn't it? This times this, you get negative 2 cos x sine x exponential sine x. That one you multiply u prime by v, isn't it? Then it is plus u v prime, isn't it? U is cos squared x, v prime is, so it becomes cos cubed, isn't it? So it is plus cos cubed x exponential sine x. Are we together? Is that okay? So have you seen, you found f triple prime of x, isn't it? You move to the last one. For us to get x raised to power 4, we must get now f fourth derivative of x, isn't it? Are we together? Yes, start. It is very simple when you move posteriorly the way I'm moving, okay? So the fourth derivative, you start with this first part. If you differentiate negative cos x exponential sine x, you see this negative outside, then inside what do we have? When you are differentiating cos x exponential x, you are differentiating this. See, you got this. Are you seeing? See, this is what you found. You found negative sine x exponential sine x plus cos squared x sine exponential sine x. That is what you found when you differentiated this part, isn't it? Are we together? So maybe this one is going to belong, let me put it here. Fourth derivative of x, let me put it there to avoid, because this space is not going to be enough, isn't it? If we differentiate this first part, we have negative outside, but the moment we differentiated cos x exponential sine x, this term, the moment we differentiated it, we got this, isn't it? So it means we are going to get negative sine x exponential sine x plus cos squared x exponential sine x. See, we are done with this first part. Then it is minus. Now, I want you to check something here. This term is the same as this term. It can be simplified, isn't it? Are you saying this is minus sine x cos x? This is also minus 2 sine x cos x. So it is the same thing. So you can simplify that. Are you seeing? This is minus sine x cos x. This is minus 2 cos x sine x. Cos x sine x is the same as sine x cos x. So So minus 1 and minus 2. So you have a total of negative 3. Isn't it? So it means this term is not there. So it means here we have minus 3 of them, isn't it? Minus 3, then it is the n plus our cos cubed x exponential sine x. Are we together? Now, differentiating this is very simple. Look the way you are going to differentiate it. Look what I want to do. You have 3 sine x. This one is very simple. You just have to be someone who can observe. Are you seeing that? You have 3 sine x cos x exponential sine x. This is integration by parts. Because you know how to differentiate cos x exponential sine x, you differentiate and you found this. Are you seeing? So you use product rule, meaning you let 3 sine x to be u and cos x exponential x to be v. Because you know the derivative of this. Are you seeing? Are you saying this where you differentiated cos x exponential sine x? So there. So you make it one thing because you've already differentiated it somewhere, isn't it? So here it means you use what? 3 sine x. So if you differentiate sine x, you get cos x, isn't it? So we are going to have 3 cos x. Are we together? Then you go to v. Your v is what? Your v is cos x exponential sine x. If you differentiate v, if you differentiate this, see you already differentiated it here. This, if you differentiated, you got this. Are you seeing? Are we together? Yes. Are you seeing what you found? Meaning this thing will just be repetition of what you found previous. Are you seeing that? You found negative sine x exponential sine x plus cos squared x exponential sine x. Are you seeing what you found? So it means when you have uv, you're supposed to get uv plus uv. This is u prime, the other one is v prime, isn't it? Good. So can you now come and add that term there? Was it plus or minus? It was minus this, isn't it? So it was minus in bracket u prime times v. U prime is this times v, isn't it? So it is minus 3 cos x times cos x. That is 3 cos x squared, isn't it? Exponential sine. Are we together? Then plus uv prime. See, this is u times v prime, isn't it? So 3 sine x times negative sine x. So you get minus 3 sine squared x, isn't it? Exponential sine x. Then again 3 sine x times cos squared x, you get plus 3 sine x cos, let me write it down here, you get plus 3 sine x cos squared x exponential sine x. You're done. You're done with that. Go to the next one. The next one is this last one. The last one, in fact, is the simplest. This last term. It is cos cubed x exponential sine x, isn't it? What do? So you remove cos squared out of it for you to remain with cos x exponential sine x. Meaning whatever you differentiate in the first, you don't waste time, is what you remove outside this, isn't it? Are you seeing it? So here we have cos cubed x exponential sine x. So this one is written in which form? It is written as x cos squared x cos x exponential sine x. Because we know how to differentiate cos x exponential x to get this. Are you getting that? Are we together there? So here we have your cos squared x to be u, cos x exponential sine x to be v, isn't it? Isn't it? Very good. So you have u is equals to cos squared x. So if you differentiate cos squared x, what do you get? We already found that in the past. Minus 2 cos x sine x. Isn't it? So it's very happy. Then the next, if you differentiate v, remember here you have v to be equals to cos x exponential sine x, isn't it? So if you differentiate v, what do you get? If you differentiate v, yes, if you differentiate v, you are supposed to get differentiating cos x sine x, differentiating this, you got this, isn't it? You got minus sine x exponential sine x plus cos squared x exponential sine x. Are we together? So you go here in the last part, it is plus, it was plus. Then you start. What were you supposed to get? You are supposed to get, if it is u, v plus u, if this is u prime, the other one is v prime. Product rule, isn't it? So u prime times v, u prime is this times v. So you get minus 2. You are going to get, in this upper bracket, you are going to get minus 2 cos x sine u prime times v. Cos x times cos x is going to be cos squared x, isn't it? Then sine x exponential sine x. You are done with that. Then it is plus u v prime, isn't it? U is cos squared x, v prime is the whole of this, isn't it? So cos squared x multiplies all the terms here, isn't it? Are we together? So cos squared x times negative this, it is going to be minus cos squared x sine x exponential sine x. Go on. Then it is plus cos squared x times cos squared x, you get cos raised to power 4, isn't it? Loss of indices, cos squared x times cos squared x, cos raised to power 4 exponential sine x. That is the end. You can see it was a very simple thing. So from there, you found f, the first derivative, the f, the first derivative, second derivative, right derivative, and fourth derivative. So the moment we get the fourth derivative means we are going to get the term x raised to power 4, isn't it? So let us now get our f's of zeros. So what is f of 0? Meaning where there is this x, you put 0, isn't it? Are we together? Yes. So what is f of 0? F of 0 is 1. Because where this x, you put 0, sine 0 is 0, isn't it? Are you seeing that? So exponential 0 is 1. Everything raised to power 0 is 1. If you get sine 0 to be 0, then exponential 0 is 1. So you get f of 0 is 1. You go to the next one. F prime of 0. We have f prime of x is here. So where there is x, if you put 0, what do you have? Cos 0 is 1. Exponential sine 0 is, meaning this exponential function, it is going to be 1 everywhere because it is exponential sine x. And x is, we are going to put 0, isn't it? So exponential sine x is 1 everywhere. Are you seeing that? So anywhere you see exponential sine x, you put 1 because sine 0 is 0. So exponential 0 is 1, isn't it? Are we together? So what you are now checking, cos 0 is what? Is 1. Are we together? Move to the next one. F double prime of 0, we are here, look here. When you put 0 here, you know exponential sine 0, this is 1, isn't it? Sine 0 is 0. So it means this time the whole of it is 0. Then here, cos 0 is 1. When it is cos squared, it means it is 1 squared. Yeah, when you've been written cos squared x, that means it is cos x which has been squared, but cos 0, because where the self you are putting 0, cos 0 is 1. So it is 1 squared, isn't it? Are we together? Good. So it means that is also 1. So look at the way this thing was very simple. Then you move to the third derivative of 0. Isn't it? So after the triple prime of 0, where there is x, you put 0. Exponential 0 is 1. So here is cos 0 is 1, isn't it? See, this now is negative 1, isn't it? See, here you have negative 1. Then it is minus what? Here is already the sine 0, meaning the whole of this goes to 0. Are you seeing? Yeah. Because sine 0 is 0, isn't it? Then it is plus cos is 1. Meaning cos 0 is 1, but 1 cubed is just 1. Exponential sine x is 1, isn't it? So it is minus 1 plus 1, meaning the whole of that thing which was giving you a headache is 0. So it means the moment you are able to get this to be 0, you don't need to waste your time looking at that, meaning that one will be. But you never know, you just check, isn't it? Are we together? So, f of the derivative of 0, start. Where there is sine x, automatic 0, isn't it? Here, see, here is 1. See, exponential sine x, that is 1 when you put 0, isn't it? It's 1. Cos is 1 squared. So you have negative 1, isn't it? Negative 1. Then come in this bracket, minus, inside the bracket, cos squared x. Cos x is cos 0 is 1. 1 squared is just 1, isn't it? See, here you remain with the 3. because exponential sign x is 1, isn't it? You remain with 3 minus, see that is 0, anyway you see sign is 0. 0, here they sign 0. So it means there we just remain with 3. We are done with that bracket, isn't it? Come to this. Have you seen what I've done there? The sign here, the whole of this is 0, the sign here, the whole of that is 0. Meaning we only remain with these 3. Isn't it? Good. Move to the last one. It is plus, the next bracket, negative 2. The sign here, the whole of this is 0. Isn't it? The sign here, the whole of that is 0. Then cos 1. Are you seeing that? Senor? So the final answer is negative. Because negative 1 minus 3 plus 1. See, that is negative 3. Yes. Very good. You need to reconfirm if you've done substitute the right thing. 0, 1, negative 1. 1, 0, 0. So you remain with 3, negative 3. Negative 1, negative 3, that is negative 4. 0, 0, 1. Isn't it? Yes, so plus 1. You get negative 3, isn't it? So we found all up to the fourth derivative of 0, isn't it? Having found that, we now come and we write the Maclaurin series. So the Maclaurin series expansion of a function of x is given by what? We start from f of 0, isn't it? Are we together? Then it is plus f of 0 if we differentiate it for the first time, meaning we are going to have x raised to power 1 over 1 factorial, isn't it? Are we together? Then the next one, f of 0, if you now differentiate it for the second time, it means we are going to have x squared over 2 factorial. Then plus, if you differentiate it for the third time, then it means we are going to have x raised to power 3 over 3 factorial, isn't it? Then plus, if you differentiate it for the fourth time, then it means you are going to have x raised to power 4 over 4 factorial. Are you seeing that? Let us now substitute. What is f of x now? Where there is f of x, put the value of f of x. F of x is equals to exponential sign x. Our f of x was exponential sign x. So it means exponential sign x is equals to what? All this. What is f of 0? F of 0 you found to be 1. So it means this is 1. Then you move f prime of 0 you found to be 1. So 1 times x raised to power 1 over 1 factorial, so you just remain with x. Are we together? F double prime of 0 you found to be 1, isn't it? So this is 1 times x squared over 2 factorial. So you remain with a half x squared, isn't it? Move to the next one. F triple prime of 0 you found to be 0, meaning the whole of this term goes to 0, isn't it? Then f fourth derivative of 0 you found to be negative 3. So negative 3 over 4 factorial. Negative 3 over 4 factorial. That is negative. Negative 1 over 8. Unless you're using a different calculator than the one I'm using in my brain. Negative. Then our x is raised to power 4. Isn't it? Are we together? So, what have we found here? We found, look at what we found here. We found exponential sign x is equals to, let us write it up here to give us space for dealing with it. We found exponential sign x to be equals to 1 plus x plus a half x squared minus 1 over 8 x raised to power 4. So we want to integrate it. Maybe if you want to integrate it, we introduce with respect to x on both sides. With respect to x on both sides. That is one term, isn't it? Then you put your limit is from 0 to, your limit is from 0 to 1. Are we together? So start integrating. If you integrate 1, you get x. Then plus, if you integrate x, you get x squared over 2. Then here we have a half. If you integrate x squared, you get x cubed over 3, isn't it? Are we together? So x cubed over 3 times a half, so you get x cubed over 6. See, here is going to be x cubed over 3, meaning 3 times 2, which is already there, isn't it? So that is x cubed over 6. Then minus, if you integrate x raised to power 4, so you get x raised to power 5 over 5. Meaning 5 times that 8 in the numerator, you get 40. So it is minus x raised to power 5 over 40. Then you put your limits from 0 to 1. Are we together? So when you substitute the lower limit, when you put 0 y-axis, it means the whole of that will go to 0, isn't it? If you substitute the upper limit, which is 1, when you put 1 y-axis, 1 raised to any power is just 1, isn't it? So it's like this is 1 plus a half plus 1 over 6 minus 1 over 40, isn't it? Would you have 1 plus a half plus 1 over 6, 1 plus a half plus 1 over 6 plus minus 1 over 40. We have 1.642. 1.642 minus 0, because the lower limit is at 2, 0, everything will be 0, isn't it? So your answer is 1.6442, and you have evaluated that particular integral using the Maclaurin series.